not that great. We've got a little bit. We've got a wobble in that. So we'll have to deal with that a little bit. See if we can't get rid of that. The other thing that we have, these time controllers are made for a nice laboratory, as you realize we're outside. So they go bad with time. So I don't trust them. I don't know, this number should be close, okay, it was at 50. This number should be close to what you're rotating. But what I want you to do, I don't have it here, it's over on a shelf. I want you to put there's a reflective tape that we have and a light tachometer. So that you put a reflective tape on this and you check it with the light tachometer so that you can prove that you're in the range. Your light tachometer is going to give you fluctuations, but you want to look at that to prove that you're in the range of where you should be, so you know the rotation.
What was that light? What?
It's a tachometer. TACHO meter.
Bruce, why do we use like rotating working electrode?
It's a very well-known geometry. It was developed years ago, but it was there's a paper by David Silverman that gives you all the calculations about it, mass transfer coefficients and everything like that. It's just something that has been used a lot for these types of tests. You can calculate the mass transfer. You can determine the wall shear stress.
So you mean that we have
there.
better results compared to like stationary working electrode inside the steering solution?
So if you have a stationary sample, your surface pH is going to change due to the ferrous ion concentration. You're going to get different results than if you're rotating. And that's actually one of the things I'm going to have you do in the experiment that you're going to do is you're going to rotate at different speeds, and we're going to show you what you get different that way. Okay, how are we on time? Yeah, we're doing good. Okay, so that's counter electrode, reference electrode, sparge tube, thermocouple, working electrode. Sparge tube is the gas in. The gas out, we usually connect up a condenser like that. And then if you need to, if you've got a temperature in here, any temperature over ambient temperature, then you need to run fluid through that so that anything that goes up comes back into your system. What else is there? Okay, then we've got to have...
Why we have to use the circulating water?
If you've got temperatures, if your temperature in your glass cell is above ambient, then you're going to be losing a little bit of liquid out. With a shorter term test, it really doesn't matter. With a longer term test, it may matter, especially if you have like acetic acid or you have something that's volatile in your test. These become very important to keep your conditions the same.
So why don't we use condenser? Condenser also
You will.
prevents vaporization of water.
Yeah. Yeah. You will. I mean, at ambient temperature, it doesn't really matter. You're not going to be losing anything, right?
So this thing retains the liquid, the vapor?
Yeah, yeah.
Okay.
So right. So if you have a higher temperature in here, your water vapor is going to be high. Your water vapor pressure, you're going to have a lot more liquid in your gas phase, and so you're always putting a gas in and taking a gas out. That's also what this is for.